You know that feeling. When your body is so tired, it's almost heavy. But your mind keeps moving anyway. That feeling has a name. It has a science. Tonight, we're going to follow it all the way to sleep. Welcome to Sleepy Science Facts. Wherever you are right now, perhaps lying still while your thoughts are anything but, allow yourself to just be here. We'll trace 100 psychology facts about the exhausted mind, from the deepest systems of your brain that regulate wakefulness to the quiet chemistry of what finally lets you rest, to the strange and beautiful truth of why tired and sleepy are not the same thing at all. These quiet explorations of the mind build a resting place for the restless. A soft subscribe, a like, or a gentle share creates a pathway for more tired minds to discover this space and brings us closer to protecting this sanctuary, one sleepy soul at a time. Your presence here means more than you know. Let yourself settle completely here. Feel your jaw unclench, your shoulders drop just a little. You don't need to hold on to any of what you're about to hear. Just notice that soothing heaviness beginning to gather at the edges of you, like your thoughts are slowly dimming their brightness, growing softer at the edges, dissolving into the peaceful fog of approaching sleep. Close your eyes and breathe deeply. You're resting in the space where your mind finally stops explaining itself. Let your thoughts dissolve like words on water. And now we begin. There is a difference between being tired and being sleepy. And your brain knows the difference, even when you don't. Tiredness, or fatigue, is a signal from your body and your cognitive systems that resources have been depleted. Sleepiness is a separate biological state, a push from a chemical called adenosine that builds in your brain throughout the day, signaling that sleep is due. When you feel exhausted but cannot sleep, these two systems have become uncoupled. The exhaustion is real, but something is preventing the sleepiness signal from taking over. Understanding this is the first step toward understanding your own restless mind. Adenosine is one of the most important molecules in your sleep life, and almost no one has heard of it. It is a byproduct of neural activity, the brain thinking, processing, regulating. Every hour you are awake, adenosine accumulates in your brain tissue. The more it builds, the heavier your mental load feels, the more your body leans toward rest. When you finally sleep, adenosine gradually clears. Levels fall as the brain cycles through its restorative stages. By morning, the signal has quieted enough that waking feels possible again. This is also why caffeine works the way it does. It blocks adenosine receptors, temporarily hiding the signal, but the adenosine itself keeps building. The tiredness never actually left. It was only postponed. Your brain runs on around 12 to 15 watts of power, less than a dim lamp, yet it accounts for roughly 20% of your body's total energy consumption. When you are mentally exhausted, that energy has been spent, not in one dramatic way, but across thousands of tiny decisions, emotional reactions, sensory inputs, and background processes running beneath your awareness. By the end of a hard day, your brain is not broken. It has simply spent what it had. The strange thing is that even this level of depletion does not guarantee sleep. Something else is also needed. The brain has two major systems that govern when you sleep. The first is the adenosine system, the homeostatic drive, tracking how long you've been awake. The second is your circadian rhythm, an internal clock synchronized primarily to light, and running on roughly a 24-hour cycle. Sleep happens most naturally when both systems align, when you're exhausted but can't sleep. These two systems are often working against each other. You have spent your resources, but your internal clock may still be signaling wakefulness. The conflict between them is one of the most common sources of the exhausted but awake experience. Your circadian clock is controlled by a tiny cluster of neurons in the brain called the suprachiasmatic nucleus, or SCN, located in the hypothalamus. It contains roughly 20,000 cells, each with its own molecular clock ticking away. These cells respond to light signals from your eyes, specifically to a type of light receptor called intrinsically photosensitive retinal ganglion cells, which are most sensitive to short wavelength blue light. When blue light hits these cells, the SCN suppresses the release of melatonin, the hormone that signals nighttime to your brain. In the modern world, screens, LED lights, and indoor lighting at night are constantly telling your SCN that it is still daytime. Your exhausted mind never fully gets the chemical permission to sleep. Melatonin is often misunderstood. It is not a sleeping pill. It does not cause unconsciousness. What melatonin does is open a biological window, a signal to the brain that darkness has arrived, that it is safe to begin the transition towards sleep in a natural light environment. Melatonin begins rising roughly 2 hours before your typical sleep time, producing what researchers call the dim light melatonin onset. In people who struggle to sleep, despite exhaustion, this melatonin window is often delayed, sometimes by hours. The tiredness is present, but the biological permission to sleep has not yet arrived. There is a phenomenon called hyperarousal, and it is one of the central mechanisms of insomnia. Hyperarousal means that certain brain systems remain in a state of elevated activation, even when the body is exhausted and the hour is late. Studies using electroencephalography show that people with chronic sleep difficulty have measurably different brain activity at night compared to healthy sleepers. There is more high-frequency beta wave activity, the kind associated with alertness and active thinking, in regions of the brain that, in healthy sleepers, go quiet. As sleep approaches, the exhausted mind that cannot sleep is not lazy or broken. It is, in a very specific way, still alert. The default mode network is a set of brain regions that become active when you are not focused on a specific task. When your mind wanders, reflects, plans, or revisits the day. It includes areas like the medial prefrontal cortex, the posterior cingulate cortex, and the angular gyrus. In people with insomnia and mental exhaustion, the default mode network tends to remain highly active at night, especially in the minutes and hours that should be devoted to falling asleep. This is the neural architecture of lying awake with your thoughts. Your mind, rather than quieting, turns inward and begins talking to itself. Rumination is the psychological term for repetitive, often circular thinking about past events or future worries. It is distinct from problem solving. Rumination does not seek answers. It returns, again and again, to the same material, generating unease rather than resolution. Research consistently links rumination to both mental fatigue and sleep disruption. The exhausted mind that cannot sleep is frequently a mind caught in a ruminative loop, too tired to engage with the world, but too activated to step away from itself. The thoughts are not productive, but they feel, in the darkness, as if they are. Here is where something begins to clarify. The experience of feeling bone-tired but unable to cross into sleep is not a single problem. It is the surface of several systems pulling in different directions at once. Adenosine builds, but the circadian clock may still be holding its wakefulness signal. Melatonin is delayed. The default mode network turns inward instead of going quiet, and a broader state of elevated arousal keeps the alert system running past its useful hours. Each of these has a biology, each has a name. Understanding them, Honor Biwan, is the beginning of finding the way through. Cortisol is your body's primary stress hormone, and it has a natural daily rhythm. It rises sharply in the early morning, a process called the cortisol awakening response, to prepare you for the demands of the day. It then gradually declines through the afternoon and reaches its lowest point in the first hours of sleep. In chronically stressed or mentally exhausted individuals, this daily rhythm becomes disrupted. Cortisol can remain elevated in the evenings, competing directly with melatonin's calming signal. The result is a brain that is chemically primed for vigilance at precisely the time it most needs to rest. The amygdala is a small, almond-shaped structure deep in the brain, and it is central to emotional processing, particularly the processing of threat and fear in a well-rested brain. The prefrontal cortex exerts significant regulatory control over the amygdala, helping to contextualize and calm emotional responses in a sleep-deprived or exhausted brain. This regulatory relationship weakens. The amygdala becomes more reactive. Small frustrations feel larger. Worries feel more present. The brain's threat detection system, with its regulatory governor quieted, begins to run at a higher baseline. This is one reason why exhaustion makes everything feel more emotionally weighted, and why emotional weight makes sleep harder to reach. Sleep pressure and stress arousal are, in neurological terms, opposing forces. Sleep pressure, driven by adenosine and the circadian rhythm, pushes the brain toward rest. Stress arousal, driven by the sympathetic nervous system, cortisol, and amygdala activation, pushes it toward readiness. In healthy conditions, by the end of the day, sleep pressure dominates and arousal fades. In the exhausted but awake state, the arousal system does not stand down. The body remains poised, as if for action that never comes. You feel it as tension in your shoulders, a mind that will not quiet, a body that sometimes stirs, searching for a danger that isn't there. The locus coeruleus is a small region in the brainstem that produces almost all of the brain's norepinephrine, a neurotransmitter closely tied to alertness and the readiness response. During normal sleep, the locus coeruleus becomes largely quiet, but in states of chronic stress, worry, or hyperarousal, this structure remains active even as the hour grows late. Norepinephrine released into the brain suppresses sleep-promoting neural circuits and sustains the alert, scanning quality of the wakeful mind. It is, in an evolutionary sense, a protective mechanism. The anxious brain stays awake because, historically, sleep during genuine threat could be costly. Tonight, however, the threat is mostly imagined, and yet the response is entirely real. Mental fatigue and physical fatigue are processed differently in the brain, and they feel different in the body. for good reason. Physical fatigue is associated with metabolic signals from the muscles and peripheral nervous system, the heaviness of limbs, the ache of joints. Mental fatigue is associated with changes in brain chemistry and neural efficiency, the sense that thinking has become slow, effortful, and unrewarding. Research shows that mental fatigue reduces the perceived ability to continue performing. You feel incapable of more effort, but it does not always reduce physiological capacity. The exhausted mind tells you it is done long before the body agrees. This is one reason why mentally tired people can still feel physically restless at night. Your prefrontal cortex, the large, forward-facing region of the brain responsible for planning, self-regulation, and the gentle guidance of attention, is extraordinarily energy expensive. It is among the first regions to show reduced efficiency under fatigue and sleep deprivation. When this region quiets, the gentler qualities of judgment and emotional balance simply become less available. Not gone, only resting. Like everything else that has worked all day, the ability to redirect unhelpful thoughts, to see the larger picture, to hold worries more lightly. These ease before other capacities do. This is not weakness. It is the natural consequence of a structure that has been present and working all day, finally growing still. Sleep researchers have identified two broad categories of insomnia: sleep onset insomnia, which is difficulty falling asleep, and sleep maintenance insomnia, which is waking during the night and struggling to return to sleep. The exhausted but awake experience most commonly involves sleep onset difficulty, though the two categories frequently overlap. Importantly, both are now understood to be driven less by the absence of sleepiness and more by the presence of something that interferes with it. Arousal, worry, conditioned wakefulness, or a disrupted circadian phase. The inability to sleep is usually not about a missing ingredient. It is about something actively in the way. There is a process called sleep state misperception, and it is more common than most people realize. In this state, a person is objectively asleep. Their brain waves, eye movements, and muscle tone all indicate sleep, but they perceive themselves as awake. Upon waking, they report having lain awake for hours, even if recordings show otherwise. This phenomenon occurs more frequently in individuals with high levels of worry, hyperarousal, or mental fatigue. It suggests that the sleeping brain, under certain conditions, maintains a thread of wakeful feeling awareness, even during genuine sleep. The exhausted mind does not always trust the rest it is getting. The glymphatic system is a remarkable waste clearance network in the brain that becomes significantly more active during sleep. Cerebrospinal fluid moves through the brain tissue, carrying metabolic byproducts, including amyloid beta and tau proteins, toward the body's drainage pathways. This process has been observed in animal studies for over a decade, where brain cells were found to expand the spaces between them during sleep, allowing fluid to flow more freely. And recent human research published in 2026 has confirmed that glymphatic clearance of these proteins into the bloodstream increases measurably during normal sleep compared to sleep deprivation. The sleeping brain is not only resting, it is, in a very real sense, being washed, and the mind that cannot sleep is being denied, quietly, the cleaning it most needs. Research published in Current Biology found a revealing clue about cognitive fatigue after a day of mentally demanding work. Concentrations of glutamate, an important neurotransmitter, were measurably higher in the lateral prefrontal cortex compared to those who had performed easier tasks. Whether this glutamate accumulation causes the feeling of mental exhaustion or simply signals it remains an open and thoughtful question among researchers. But the finding suggests something meaningful. Mental fatigue, asa real, measurable biology. One that the brain, given rest, appears to gradually and quietly resolve. The tired mind is not imagining its heaviness. It is reading a real chemical signal, and that signal, like all signals, eventually quiets. Decision fatigue is a related but distinct phenomenon. The more choices a person makes throughout a day, the more depleted their capacity for careful decision-making becomes. Studies of judicial decisions, medical recommendations, and everyday choices consistently show that decision quality changes as a session continues and is restored after breaks. By the end of an ordinary day filled with hundreds of small decisions, what to eat, what to say, how to respond, the prefrontal machinery of deliberation is genuinely worn. The mind that cannot sleep at night is often a mind that has been deciding all day, even about things that seemed trivial at the time. Emotional labor, the effort of managing, suppressing, or performing emotions in social situations, is one of the most cognitively and neurologically taxing activities a person can engage in. Nurses, teachers, caregivers, service workers, and anyone in a role requiring sustained emotional attunement carry a particularly high load of this kind of fatigue. Research shows that emotional labor activates many of the same neural circuits as other demanding cognitive tasks and depletes similar resources. By evening, people who have spent their day emotionally regulating themselves and others are not simply tired in a general way. They are specifically worn in the very systems that would otherwise help them transition to sleep. The relationship between worry and sleep is bidirectional. Worry makes sleep harder to reach, and insufficient sleep makes the mind more prone to worry. This creates one of the most common and frustrating loops in mental health. A difficult night leaves the nervous system more reactive and the prefrontal cortex less able to provide its steadying influence. The next day feels harder. By evening, the unsettled feeling is higher, making the next night harder still. Understanding this loop does not immediately break it, but it does something worthwhile. It removes the self-blame. The person lying awake is not doing something wrong. They are caught in a neurological feedback system that needs gentle interruption, not judgment. There is a concept in behavioral sleep medicine called conditioned arousal, or learned wakefulness. Over time, particularly in people who regularly lie awake in their beds, the bedroom itself can become associated with wakefulness. The brain, which learns associations rapidly and durably, begins to link the bed, the pillow, the darkness, the particular quality of nighttime silence with the state of being awake and alert. The bed, which should be a refuge, becomes a signal for something else. This is not a character flaw. It is the same learning mechanism that allows any creature to anticipate patterns applied, unfortunately, to the one place that should feel most safe. Now, a portrait is emerging. The exhausted mind that cannot sleep is not one thing. It is a convergence. Adenosine builds, but the circadian clock hesitates. Cortisol remains elevated into the evening. The amygdala runs at a higher baseline. The default mode network will not quiet. The prefrontal cortex has spent its resources, glutamate and other metabolites, accumulating key regions. Emotional labor goes unprocessed. Worry and sleeplessness sustain each other, and the bedroom itself may have come to carry an association with wakefulness. Every single one of these elements is real. Every single one has a biology, and none of them, not one, is a reflection of who you are or what you deserve. You are a complex system, moving through a complex world. Rest is possible, but it often has to be understood before it can be found. Let's pause here and notice your body as you breathe out slowly. Appreciate each tiny cell inside. Trillions of organisms working in silence, heart beating, lungs breathing, brain thinking, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. Your nervous system is already trying to shift. You don't have to help. You only have to stop resisting. You are a complete ecosystem, quietly, beautifully, self-balancing. Now we continue. The nervous system has two primary modes of operation. The sympathetic nervous system drives the readiness response, increasing heart rate, dilating pupils, redirecting blood toward large muscles, flooding the body with adrenaline and cortisol. The parasympathetic nervous system governs rest and restoration, slowing the heart, relaxing smooth muscle, facilitating the physical conditions necessary for sleep. Sleep requires parasympathetic dominance, but in a hyper-aroused, exhausted individual, the sympathetic system often refuses to stand down. The body remains in a physiological posture of readiness, even as the mind and heart desperately want to rest. The vagus nerve is the longest cranial nerve in the body, running from the brainstem through the heart, lungs, and digestive system. It is the primary conduit of the parasympathetic nervous system, and its activation is closely associated with calm, rest, and the transition into sleep. Slow, deep breathing is one of the most reliable ways to stimulate vagal activity, to literally signal to the body that it is safe. This is not folklore. Vagal stimulation has measurable effects on heart rate variability, cortisol levels, and inflammatory markers. The breath is a real tool, and the body is genuinely listening. Heart rate variability, or HRV, is a measure of the variation in time between successive heartbeats. A healthy heart does not beat with perfect metronomic regularity. It accelerates slightly on the inhale and slows on the exhale. A pattern called respiratory sinus arrhythmia, higher HRV, is associated with greater parasympathetic activity, better emotional regulation, and more restorative sleep. Lower HRV, a more rigid, less variable pattern, is associated with stress, poor sleep, and fatigue. Measuring HRV has become a meaningful marker of recovery, used by researchers and clinicians alike to assess whether the nervous system has genuinely rested. The body's temperature follows a precise daily rhythm, and it is deeply tied to sleep. Core body temperature begins to drop in the late evening, reaching its lowest point in the early morning hours, around 4 to 5 in the morning. This cooling is not incidental. It is one of the key signals that initiates sleep. The brain needs to cool to enter and maintain its sleep stages properly. Taking a warm bath or shower before bed actually helps this process. The body compensates by releasing heat through the skin, cooling the core more efficiently afterward. Comfort in sleep is not a luxury. It is a physiological state that the body actively constructs. Magnesium is a mineral involved in over 300 biochemical reactions in the human body, and its connection to sleep is increasingly well supported by research. It is required for the activation of GABA receptors, the primary inhibitory neurotransmitters in the brain that quiet neural activity and facilitate the transition to sleep. It also helps regulate the hormonal system responsible for the stress response. Many adults in industrialized countries have insufficient magnesium through diet alone. While it is not a complete answer to complex sleep difficulties, the relationship between magnesium and sleep quality is real and physiologically grounded. GABA, gamma-aminobutyric acid, is the brain's primary inhibitory neurotransmitter, where excitatory neurotransmitters like glutamate activate neurons. GABA quiets them. The transition from wakefulness to sleep is essentially a GABA-dominated event. The gradual inhibition of wake-promoting circuits, allowing sleep-promoting ones to take over. Many sleep medications work by enhancing GABA's activity at its receptors, but the brain also produces GABA naturally, and activities that support healthy GABA function, including regular sleep itself, physical movement, and reduced chronic stress, remain the most enduring form of care for this system. Serotonin occupies an interesting position in the sleep story. It is commonly associated with mood regulation and well-being. It is also the chemical precursor to melatonin, converted in the pineal gland in the presence of darkness. During the day, serotonin is released in wake-promoting pathways and supports alertness, mood, and appetite. At night, it becomes the raw material from which melatonin is made, initiating the sleep signal. This means that when serotonin pathways have been depleted by chronic stress or emotional weight, both daytime mood and nighttime melatonin production can be affected together. The tired, low-mood mind that cannot sleep may be moving through both of its burdens at once. Dopamine is another neurotransmitter with a complex role in sleep. In its wake-promoting function, dopamine supports motivation, reward-seeking behavior, and alert engagement with the environment. At night, healthy sleep requires dopamine activity to ease in certain pathways, but chronic overstimulation of dopamine systems through screens, high-novelty environments, or the constant pull of something new can make it physiologically harder for these pathways to quiet down. The brain that has spent its day seeking small moments of stimulation may arrive at night in a state of low-level restlessness, searching for the next input, even when the body is lying still. The habit of reach leaves its trace in the wiring. Orexin, also known as hypocretin, is a neuropeptide produced by a small number of neurons in the hypothalamus, and it is one of the most powerful wake-promoting chemicals in the brain. Orexin neurons project widely throughout the brain, stabilizing the wakefulness state and preventing inappropriate transitions into sleep. In the hyperaroused, exhausted mind, orexin activity may remain elevated into the night, sustaining the alert state against the body's wishes. The newest class of sleep medications, called orexin receptor antagonists, work specifically by gently reducing orexin signals, a targeted approach that reflects how precisely this system is now understood. Chronic low-grade inflammation is emerging as an important factor in the relationship between mental fatigue and disrupted sleep. Inflammatory cytokines, chemical messengers released by the immune system, can influence brain function in ways that produce fatigue, low mood, and cognitive slowing. This is the biological basis of the exhausted, foggy feeling that accompanies illness, but low-grade chronic inflammation, driven by prolonged stress, poor diet, or disrupted sleep, can produce a similar, milder version of this state. The exhausted but awake mind may, in some cases, be living in a gently dysregulated inflammatory state that simultaneously drives tiredness and makes sleep harder to reach. Sleep itself has restorative effects on the body's inflammatory balance. During slow-wave sleep, the brain reduces the activity of many inflammatory pathways and restores the regulatory systems that normally keep them in check. This creates a bi-directional relationship between inflammation and sleep. Inflammation makes sleep harder, and disrupted sleep allows inflammation to persist. This loop is particularly relevant in conditions like prolonged stress and burnout, states in which the inflammatory balance has drifted, and sleep, the body's most natural form of repair, has temporarily moved out of reach, not gone, only waiting for conditions to ease. Burnout is a state recognized by the World Health Organization as an occupational phenomenon characterized by emotional exhaustion, a sense of distance from one's work, and a reduced feeling of personal efficacy. Neurologically, burnout shares features with both depression and chronic fatigue, including dysregulation of the body's stress hormone system, reduced prefrontal activity, amygdala reactivity, and disturbed sleep architecture. People experiencing burnout commonly report the paradox of being profoundly exhausted while also unable to sleep. The system has been pushed beyond its regulatory capacity, and neither the activity nor the rest mechanism is working as it should. The experience of being deeply fatigued while simultaneously alert or mentally restless is sometimes described in popular terms as being tired but wired. The underlying biology is more accurately described as dysregulation of the body's stress response system, a state in which cortisol patterns have become flattened, reversed, or erratic, rather than following their natural daily rhythm. This dysregulation produces a state in which the body lacks the appropriate hormonal support for either vigorous wakefulness or restful sleep. It exists in a kind of between, neither fully engaged with the world, nor able to truly leave it. Sleep architecture. The structure of a full night's sleep is not a uniform state of unconsciousness. It is a highly organized sequence of stages that cycle roughly every 90 minutes. Light sleep transitions into slow-wave deep sleep, and then into REM sleep, rapid eye movement sleep, in which most vivid dreaming occurs. Each stage serves distinct biological and psychological functions. Slow-wave sleep is when physical restoration, immune support, and lymphatic clearing are most active. REM sleep is when emotional processing, memory consolidation, and creative integration occur. The exhausted mind that only reaches light sleep before waking is being denied not just quantity, but the specific quality of restoration each stage provides. Here, at the midpoint of our early journey, the evidence points towards something important. The exhausted mind that cannot sleep is not at war with itself without reason. Every element of its struggle, the elevated cortisol, the active amygdala, the lingering orexin, the inflammatory drift, the disrupted architecture, has a logic. It is a system that learned, over time, to stay ready, often for very understandable reasons. The path forward is not to fight the readiness, but to gently, patiently, create the conditions in which it no longer feels necessary. This is what the rest of our journey will trace. The quiet science of how rest is allowed back in. Take a gentle breath. Feel the weight of your body. Heavy, still, real. We're exploring consciousness itself tonight. The very thing doing the exploring right now. Strange, beautiful, and perfectly calm. Just notice where your mind is. Don't judge it. Just notice. Let's drift onward together. Mindfulness, the practice of non-judgmental, present moment awareness, has been studied extensively in relation to sleep. A landmark study published in JAMA Internal Medicine found that a mindfulness meditation program significantly improved sleep quality in older adults with sleep disturbances, with effects comparable to other established approaches. Mindfulness appears to work by reducing arousal, quieting the default mode network, and weakening the ruminative loops that sustain nighttime wakefulness. It is not a quick fix, but as a practice developed over time, it changes the brain's relationship to its own activity. Thoughts begin to feel less like commands and more like passing weather. Stimulus control therapy is one of the most evidence-supported behavioral approaches for insomnia. Its core principle is simple. Only use the bed for sleep. This means getting up when unable to sleep, avoiding lying awake in bed for extended periods, and gradually rebuilding the brain's association between the bedroom and sleep rather than wakefulness. It works because of conditioning. The same mechanism that created the difficulty in the first place, by consistently pairing the bed with actual sleep, rather than lying awake restlessness. The brain gradually relearns what the bedroom means. The process is patient rather than comfortable, but its effects are durable. Cognitive behavioral therapy for insomnia, or CBTI, is currently the recommended first-line treatment for chronic insomnia. According to major sleep medicine organizations, it combines stimulus control, sleep restriction, gentle cognitive restructuring of sleep-related beliefs, and relaxation technique. Reviews consistently show that CBTI produces lasting improvements in sleep onset and sleep efficiency, with effects that outlast those of sleep medications over time. Crucially, it works not by adding anything to the brain's chemistry, but by changing the behavioral and cognitive patterns that have disrupted the brain's natural sleep mechanisms. The brain, it turns out, can be guided back toward trusting sleep again. Sleep restriction therapy, one component of CBTI, involves gently limiting time in bed to closely match actual time spent sleeping, then gradually expanding as sleep efficiency improves. It sounds counterintuitive, but by consolidating sleep into a tighter window, it deepens the homeostatic sleep drive, reduces conditioned wakefulness, and makes sleep more efficient and restorative. In a sense, it temporarily increases the very adenosine pressure that the restless mind has been unable to fully respond to over several weeks. Most people experience a meaningful and lasting shift in their relationship with sleep. The role of physical movement in sleep quality is well supported by research. Regular moderate intensity aerobic activity, walking, swimming, cycling, improves sleep onset, increases time in slow-wave sleep, and reduces nighttime awakenings. The mechanisms include the regulation of cortisol rhythms, the reduction of inflammatory markers, and the physical depletion that gently enhances the homeostatic sleep drive. The timing of movement matters. Morning and afternoon activity supports circadian alignment. Late evening, vigorous activity can, for some people, elevate core temperature and sympathetic activity enough to delay sleep onset. The body, like the mind, too does better with movement that arrives at the right point in the day. Light exposure is one of the most reliable tools for resetting the circadian clock, and its importance extends far beyond avoiding screens at night. Morning bright light exposure, ideally outdoor sunlight, directly activates the suprachiasmatic nucleus and anchors the circadian rhythm earlier in the day. This earlier anchor means that melatonin also rises earlier in the evening, making the sleep window more aligned with the desired bedtime. For people whose sleep clock has gradually shifted later, consistent morning light is among the most effective non-pharmacological approaches available. The sun, arriving through the eyes in the morning, sets the entire day's hormonal rhythm in motion. Temperature is a lesser-known but physiologically meaningful influence on sleep onset. Core body temperature must fall to initiate sleep, and a warm bath or shower taken 1 to 2 hours before bed accelerates this process by drawing blood to the skin surface, releasing heat and cooling the core. Studies have shown that this simple practice can reduce sleep onset and improve subjective sleep quality in meaningful ways. The body's own thermoregulatory machinery, when given the right conditions, does the rest. Comfort in sleep is not trivial. It is a physiological state that the body actively works to create, and small changes in the environment can offer real support. The relationship between nutrition and sleep is bidirectional and genuinely considered by researchers. High sugar diets, large meals close to bedtime, and alcohol, which fragments sleep architecture and suppresses REM, all interfere with sleep quality in documented ways. On the other side, foods containing tryptophan, an amino acid that serves as a precursor to serotonin and melatonin, may support the sleep onset process. Turkey, dairy, certain nuts and seeds, and oats all contain tryptophan. The gut-brain axis, through which the microbiome communicates with the central nervous system, is also increasingly understood to influence sleep regulation in ways researchers are actively mapping. The body's chemistry and what we offer it each day are quietly in conversation. The psychological concept of sleep effort, the degree to which a person tries hard to fall asleep, is paradoxically associated with worse sleep outcomes. This is sometimes called the paradox of control in sleep. The harder a person tries to force sleep, the more they activate the very arousal systems that prevent it. Attention and intention are activating the brain, when directed to sleep immediately, increases its monitoring of its own state. which is itself an alert. Vigilant behavior. Research supports the counterintuitive conclusion that a more passive, accepting, almost unhurried stance towards sleep, not trying to sleep, simply allowing the conditions for sleep, is associated with better outcomes. Halfway through our journey, something clear has emerged. The exhausted mind that cannot sleep is not, at its core, failing at sleep. It is succeeding, with remarkable thoroughness, at staying awake. The same systems that help it navigate a complex, demanding world have learned to persist long past their useful hours. Cortisol, orexin, norepinephrine, the default mode network. Each evolved for good reasons and does its job with dedication. What the exhausted mind most needs is not effort, it is permission, quiet, repeated, passion, permission, and the science of how that permission arrives is exactly what the second half of this journey will carry us toward. Breathe slowly now. Every memory you carry, every thought that still tugs at you, is being gently processed by your brain, even as you drift. Right now, your mind is writing tonight into the softer language of rest. You do not need to understand it. You do not need to help. Each breath you take is one more moment of quiet recovery that requires nothing from you. We'll continue now. Sleep is not passive. It is one of the most active, purposeful states the brain enters during REM sleep. The brain is nearly as active as during wakefulness, but the nature of that activity is different. The logical, sequential thinking of the waking prefrontal cortex gives way to associative, emotional, and imaginative processing. Memories are replayed, integrated, and connected in new ways. Emotional experiences are processed with the amygdala's intensity somewhat muted, allowing a kind of safe re-engagement with difficult material. This is why sleep, after learning, improves memory, and why sleep after hard days softens their emotional weight. The night does work that the day cannot. Dreams appear to serve a function in emotional regulation, a process some researchers describe as overnight processing. During REM sleep, the brain revisits emotionally significant experiences, but with norepinephrine, the stress neurochemical, at its lowest levels of the 24-hour cycle. This creates a unique chemical environment in which emotional memories can be reactivated and processed without the full force of their original charge. People who sleep following emotional events often report lower distress about those events than those who remain awake. The dream is not noise, it is the mind working gently and thoroughly on its unfinished feelings. Memory consolidation, the process by which new experiences and information are stabilized into long-term memory, is critically dependent on sleep. During slow-wave sleep, the hippocampus, which acts as a temporary holding area for new memories, replays the day's experiences to the neocortex, where they are integrated into existing knowledge structures. Without sufficient slow-wave sleep, this transfer is incomplete. Information is retained less durably. Connections between ideas are less stable. And the next day begins from a slightly more depleted foundation. The brain that cannot consolidate its learning is like a library where books are never properly shelved. Procedural memory, the memory of how to do things, from riding a bicycle to playing a musical phrase, is consolidated primarily during REM sleep. Studies have shown that people who sleep after learning a new motor skill perform measurably better than those who remain awake. Even when total practice time is equal, the sleeping brain continues rehearsing the skill in its own quiet way. This is one reason why musicians, athletes, and others who prioritize sleep report a quality of performance that effort alone cannot fully explain. The skill is there, but sleep is what makes it reliably available. The immune system is intimately connected to sleep. During sleep, the body releases cytokines, proteins that support the immune response. At higher rates, T-cell production, central to adaptive immunity, is significantly enhanced during sleep. Research has found that people who sleep 6 hours or fewer per night are more than 4 times as likely to develop a cold when exposed to a rhinovirus, compared to those who sleep more than 7 hours. This association held regardless of age, stress levels, income, or other lifestyle factors. The body's defenses are built at night, quietly, without fanfare, in ways that no supplement or effort can fully replicate. Growth hormone, essential for tissue repair, to muscle maintenance, and metabolic health, is released primarily during slow-wave sleep, in the first portion of the night. In adults, it remains important for cellular repair and physical recovery. The body's most significant repair work is not done in the gym or the doctor's office. It is done in the dark, in the quiet, in the slow-wave depths of an undisturbed night, and it begins within the first hours of sleep. Another reason why those early hours, so often sacrificed to late nights, carry more biological weight than we commonly recognize. The relationship between sleep and appetite regulation is real and increasingly well understood. Sleep deprivation alters the balance of two hormones, ghrelin, which stimulates appetite, and leptin, which signals fullness. After a poor night, ghrelin rises and leptin falls, creating a biological drive toward eating more, particularly foods that are higher in calories. The exhausted mind is not simply reaching for comfort foods out of habit. It is responding to a genuine hormonal signal generated by its own insufficient rest. The biology of food craving is written, in part, in the language of sleep. Cardiovascular health and sleep are deeply linked. Chronic short sleep, consistently fewer than 6 hours per night, is associated with higher rates of elevated blood pressure, coronary artery concerns, and stroke. During sleep, blood pressure naturally drops by 10 to 20% in a process called nocturnal dipping. This dip is essential for cardiovascular recovery. In people with disrupted sleep, this dip is reduced or absent, leaving the heart and blood vessels under sustained pressure throughout the night. The quiet hours of sleep are not idle. They are the cardiovascular system's most important window for restoration. Émotionnel attunement, the capacity to perceive and respond to the feelings of others, is meaningfully affected by sleep. Sleep-deprived individuals show reduced ability to recognize subtle emotional cues in facial expressions, greater tendency to interpret ambiguous situations as negative, and a diminished sense of empathy. This is not a fixed trait. It is a state, one that changes with the quality of the previous night's sleep. The person who seems less present, more brittle, or harder to reach after a difficult night is not showing their true character. They are showing the face of a brain that has not yet had time to restore its most human capacities. Creativity is among the most sleep-sensitive of all cognitive capacities. REM sleep, in particular, supports the kind of associative thinking that underlies novel problem-solving, insight, and unexpected connection-making. The well-known experience of waking with a solution that seemed out of reach the night before is not coincidence. During sleep, the brain relaxes the linear, logical constraints of waking thought and allows distant associations to be explored. The artist, the scientist, and the problem solver who sleeps well are not simply rested, they are accessing a mode of cognition that wakefulness itself makes unavailable. There is a state called hypnagogia, the transitional zone between wakefulness and sleep, in which the mind produces a unique kind of imagery, vivid, fragmentare. Loosely associated images arise in the minutes just before sleep. Many artists and thinkers throughout history have described this state as a source of unusual creative awareness. Salvador Dali famously used a technique, holding a spoon over a metal plate so it would fall when he drifted off, to gently return from hypnagogia and capture its imagery. The mind at the threshold of sleep is doing something genuinely different from anything it does while awake, and it has always been worth attending to. Micro-sleep episodes. Brief, involuntary lapses in awareness lasting from a fraction of a second to 30 seconds begin occurring after sufficient sleep deprivation. The person experiencing a microsleep is unaware of it. Their eyes may remain partially open. They continue appearing awake, but the brain has briefly entered its own version of rest. These episodes represent the brain finding, however imperfectly, the rest it has been denied. The body does not ultimately accept indefinite wakefulness. In one way or another, it finds its path toward the rest it requires. There is a neurological model of sleep onset called the flip-flop switch, proposed by researchers, including Clifford Sapir at Harvard Medical School. In this model, wake-promoting neurons and sleep-promoting neurons are mutually inhibitory. Each side suppresses the other. This creates a switch-like quality to sleep onset rather than a gradual fade. There is a point at which the balance tips and sleep moves in relatively quickly. This model helps explain why sleep feels as though it arrives somewhat suddenly, because at the neural level, the transition can be rapid. The question for the exhausted mind is simply, what keeps the wake side weighted down? When the body needs the switch to tip, the ventrolateral preoptic area, or VLPO, is a small cluster of neurons in the hypothalamus that plays a central role in initiating and maintaining sleep. VLPO neurons become active during sleep and release inhibitory neurotransmitters, including GA, BA, that suppress the wake-promoting systems throughout the brain. When VLPO neurons are functioning well, they are the quiet architects of rest, gradually accumulating influence across the evening until the sleep switch is ready to move. Supporting them means reducing the competing signals, the light, the unresolved stress, the conditioned wakefulness that delay their work. We now understand that the exhausted mind that cannot sleep is, in most cases, a mind whose sleep switch has been held in the wrong position by the accumulated forces of modern life, the light that delays melatonin, the stress that sustains cortisol, the screen that holds dopamine arousal, the worry that keeps the default mode network active. The bed that has come to be associated with wakefulness, each of these is a weight on the wrong side of the switch. Understanding them, naming them, is the beginning of gently be on, shifting the balance back. Nature exposure, time spent in natural environments, including forests, parks, coastlines, and open green spaces, has measurable effects on the nervous system and sleep. Studies have found that time in nature reduces cortisol levels, lowers heart rate, increases heart rate variability, and supports the parasympathetic shift that facilitates sleep. In Japan, the practice of Shinrin-yoku, forest bathing, has been studied formally for decades, with consistent findings of reduced sympathetic activity and improved mood. The exhausted urban mind is, in part, a mind deprived of the sensory environment in which human nervous systems evolved to settle. Social connection is a sleep factor that is often overlooked. Research consistently shows that loneliness is associated with poorer sleep quality, more nighttime awakenings, and greater hyperarousal. The reason appears to be evolutionary. For social animals, isolation signals vulnerability. The brain of a lonely person remains more vigilant at night, less willing to surrender to the openness of deep sleep. Conversely, a felt sense of social safety, the knowledge that others are near, that one is known and cared for, supports the parasympathetic state that makes sleep possible. Your nervous system notices whether it is alone, and it responds accordingly. Gratitude, the practice of noticing and gently acknowledging what has been good, has been shown in controlled studies to improve sleep quality. Participants who wrote down several things they were grateful for before bed fell asleep more easily and stayed asleep longer than those who did not. The mechanism appears to involve a redirection of the default mode network away from ruminative, rehearsal-based thinking and toward a quieter, more contented quality of attention. This is not wishful thinking. It is a specific, measurable shift in how the mind chooses to spend its final waking moments. Writing, journaling, expressive writing, or simply listing the thoughts on one's mind before bed has been shown to reduce sleep onset time. In several studies, one study found that writing a to-do list of future tasks before bed helped participants fall asleep measurably faster than those who reflected only on what had already been done. The act of externalizing mental content, placing it on paper, appears to reduce the brain's felt need to keep it actively circulating. The mind can rest more easily when it trusts that nothing important has been lost. The pen, in this sense, becomes a form of permission, the practice of progressive muscle relaxation, systematically tensing and releasing muscle groups from the feet upward, is one of the oldest and most consistently supported behavioral techniques for reducing physical arousal at night. By deliberately creating tension and then releasing it, the body learns to recognize and deepen the contrast between holding and letting go. Over time, this practice trains the nervous system to access a lower baseline arousal state. Studies support its value for both sleep onset and subjective sleep quality. The body, it turns out, remembers how to relax. It sometimes needs to be shown the contrast before it can fully find the release. Diaphragmatic breathing. Slow, deep breathing, using the diaphragm rather than the chest, activates the parasympathetic nervous system through multiple pathways, It increases carbon dioxide levels in the blood, which has a calming effect on neural activity. It directly stimulates the vagus nerve. It slows the heart rate and gently reduces blood pressure, and it shifts attentional focus from circular thought to physical sensation, partially interrupting the ruminative loops of the default mode network. A breath rate of around 5 to 6 breaths per minute, roughly 5 seconds in, 5 seconds out, appears to produce meaningful parasympathetic activation. This is a pace that almost anyone can practice. Anywhere, at any time. The body scan, a mindfulness practice of slowly directing non-judgmental attention through each part of the body in sequence, is used in sleep medicine as both a relaxation technique and a form of present moment grounding. By anchoring attention to physical sensation, it gently removes the mind from the thought-driven spirals of rumination and places it in the immediate, non-narrative experience of simply inhabiting a body. Research supports its value as a component of mindfulness-based approaches to stress and insomnia. The body, when attended to with curiosity rather than judgment, tends to grow quieter. It is a kind of coming home. Napping carries a nuanced relationship with nighttime sleep. Short naps of 10 to 20 minutes can restore alertness and reduce the effects of acute fatigue without meaningfully reducing the homeostatic sleep drive for the night. Longer naps, particularly those lasting 60 to 90 minutes and entering slow-wave sleep, may reduce nighttime sleep pressure and carry a greater chance of grogginess upon waking. For people with sleep-onset difficulties, daytime napping is generally approached with care because it spends some of the adenosine buildup that would otherwise support nighttime sleep. For shift workers and those managing acute deprivation, the calculus is different. Context, as always, matters. Light therapy. The use of a bright light box emitting 10,000 lux of white light, used for 20 to 30 minutes in the morning, is a well-established, evidence-based approach for seasonal affective concerns, delayed sleep phase syndrome, and circadian misalignment. It works by entraining the suprachiasmatic nucleus to an earlier phase, shifting melatonin onset earlier, and allowing evening sleepiness to arrive sooner. For people whose sleep clock has gradually drifted later, who find themselves unable to sleep before 2 or 3 in the morning, not from worry, but from a genuine circadian phase shift, morning light exposure is often the most meaningful available tool. By this point in our journey, something has shifted. We have moved from the mechanisms of the exhausted mind toward a quiet, practical understanding of how the mind and body find their way back to rest. The answer to why a tired mind cannot sleep has many layers, and the path towards sleep has many forms. Not all of them work for every person. Not all of them work immediately, but all of them rest on the same foundation. The brain and body want to sleep. They are built for it. What is needed is not to force them, but to remove, honor, be on, what stands in the way. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Every cell in your body knows how to rest. This has happened countless times before tonight. Your heart beats without instruction. Your breath moves without effort. You don't need to hold on to anything. Let the body do what it knows. Let everything unfold in its own time. Like the tide pulling back from shore. Unhurried. Unresisting. Simply moving. We're almost there now. Sleep is not a destination you arrive at. It is a direction you move in. Each breath that slows, each thought that softens, each muscle that releases. These are not failed attempts. They are sleep, arriving in stages, the way dusk arrives before night, gently, without announcement, simply becoming. The brain, at the edge of sleep, does something remarkable. It begins to release its grip on language. Thoughts become less like sentences and more like images. The internal narrator grows quieter, something older and simpler takes over. This is not unconsciousness. It is the beginning of a different kind of awareness. Softer, less demanding, more forgiving of itself. You have been awake for many hours. In that time, adenosine has been building, a quiet chemical tide of tiredness, rising slowly behind your awareness. It is very present now. It wants only one thing. You do not have to help it. Only allow yourself to stop working against it. The part of you that worries, plans, and reviews, the analytical, narrative self, draws on prefrontal cortex activity, and the prefrontal cortex is one of the most sleep-sensitive regions of the brain. It is already growing still, already withdrawing its commentary. The thoughts becoming fewer now is not failure. It is the brain gently restoring itself, the way it always has, the way it always will, somewhere in your brain tonight. VLPO neurons are gathering. They are quietly inhibiting the wake systems. Onebu-1. Patiently. You cannot feel this directly, but it is happening. The architecture of sleep is being assembled in your neural tissue. Without your permission or assistance. It has always known the way. It knows it still. Your breathing, right now, is probably a little slower than it was when we began. This is not something you chose. Your brainstem is managing it, as it has for your entire life. Every breath you have ever taken, across every night you have ever slept, arrived without effort. Tonight is no different. The next one is already on its way. The body loses water gently through breathing and warmth. As the night deepens, the metabolism does not stop in sleep. The lungs continue. The kidneys filter. The liver processes. You are not still in sleep. You are quietly, thoroughly, doing the maintenance that the day's busyness could not allow. The body is never more productive than when it rests. The brain produces theta waves, slow, rhythmic electrical oscillations. In the early stages of sleep and in states of deep relaxation, these are the same waves found during meditation, daydreaming, and creative absorption. You may be producing them right now. Theta is a bridge state. The mind is still present, but loosely, like a hand letting go of something it no longer needs to hold. The average person, sleeping 8 hours a night across a lifetime, will spend roughly a third of their entire life in sleep. This is not lost time. It is the foundation on which all the waking hours are built. Without it, the waking hours become less. With it, they become more. Sleep is the infrastructure of everything else, the quiet ground beneath every bright thing. Somewhere in the world right now, thousands of researchers are studying sleep. In laboratories from Tokyo to Toronto to London, scientists are watching brains move through the stages of the night, measuring the chemistry of restoration, mapping the geography of the dreaming mind. Sleep, once considered a simple absence of wakefulness, is now understood to be among the most complex and essential activities of the human brain, and all of it says the same thing. Rest matters, deeply, measurably, irreversibly. There is recovery after difficult nights, after sleep debt, The body prioritizes slow wave sleep and REM sleep in the nights that follow. It makes up what it most needs first. The brain is not punitive about missed rest. It is practical. It takes what it can, when it can, and continues the work. Tonight is one such opportunity. Every quiet hour between now and morning is a form of gentle repair. The word sleep comes from the Old English slupan, which shares roots with words meaning to relax, to yield, to let go. There is a long history, written into language itself, of understanding sleep as a form of releasing, not defeat, not absence, but the ancient, necessary act of setting down the day, setting down the self, setting down the effort of being a person in the world. Cultures across history have honored this releasing, each in their own way. Tonight, you join a very long and very quiet tradition of people who have simply, finally, let go. Your brain creates entire worlds while you sleep. Every night, in the gentler hours of the dark, your mind constructs vivid experiences from memory fragments, emotions, and abstract patterns. Characters appear, conversations unfold, and landscapes emerge, all generated from within. These dream worlds feel real in the moment, complete with their own logic and sensation. Yet, they vanish upon waking, like morning mist dissolving in the light. The sleeping brain is not resting. It is creating, processing, weaving the day's experiences into the fabric of who you are becoming. You are not alone in this night. Across the world, at this precise moment, hundreds of millions of people are also drifting towards sleep, in quiet rooms and noisier ones, in cities and open countryside, each carrying their own tiredness, their own thoughts, their own quiet desire for rest. You are one point in a vast human constellation of people trying, in the dark, to let go. There is something companionable in that, something gentle and true. So why does the exhausted mind struggle to sleep? We have traveled far enough to say, because it learned, very thoroughly, to stay awake, and learning, as the brain has always known, can be revised. New patterns can be laid down. New associations can form. New rhythms can establish themselves. None of this happens in one night. But tonight, from this quiet, soft, unhurried night, is one thread in the weaving. Sleep comes most easily to the mind that has given up trying to control it. This is the final paradox. All of the science, all of the understanding, all of the gentle strategies, their purpose is not to force sleep, but to remove the obstacles that prevent it. Once the obstacles ease, sleep arrives on its own. It has been waiting. It has always been waiting. Only the willingness to step aside was ever needed. Melatonin, rising now in the darkness, is not commanding sleep. It is only opening the door. The rest, the actual crossing of the threshold, is something the body does on its own terms. When it is ready, when the warmth and the quiet and the chemical conditions are right, you cannot rush it, but you can be still. You can be here, and here is exactly the right place to be. The hippocampus is taking notes tonight, not on what you've been worrying about, on what you've been feeling, on where you've been, and what mattered in a few hours. In the slow wave depths of sleep, it will begin moving the day's meaningful material into longer storage. The things that will stay are being chosen now, quietly, without your oversight, Trust the process. It has been doing this your whole life. Your heart rate is probably a little lower now than when we began. Your breath has slowed. These are not accidents. They are the body making room for what comes next. It knows what it is doing. It has always known. You have only ever needed to allow it the space to do so. The last fact of the journey is not a fact at all. It is a simple observation. You made it here, through the explanation, through the understanding, through the gradual, patient tracing of why a tired mind struggles to rest. And somewhere along the way, some of the struggle may have softened, not because anything was solved, but because understanding, even partial, even gentle, eases the fear, and without the fear, sleep can finally find you. The deepest truth of sleep science, arrived at after decades of research, is also the oldest. The body wants to rest. Sleep is not something you achieve. It is something you allow. The brain is already leaning toward it. The chemistry is already shifting. You have done nothing wrong. You are only here, now, at the edge of the night, letting go. Rest is not passive. It is the brain's most thorough form of self-care. In the hours ahead, you will be consolidated, repaired, emotionally processed, and metabolically restored. Your brain will be gently cleared by the glymphatic tide. These are not small things. They are the reason the day to come is possible at all. Rest is not the pause between living. It is a part of living itself. Somewhere in the brainstem, the locus coeruleus is finally growing still. Norepinephrine is easing. The amygdala is settling. The default mode network is losing its narrative thread. Adenosine, patient and persistent, is winning at last. The switch is tipping, slowly, gently, inevitably, the way all natural things tip. Not by force, but by the quiet accumulation of what is already true. There is nothing left to solve tonight. No thought that urgently requires your attention. No problem that cannot wait for morning, when you will have more capacity, more clarity, more patience. The night belongs to a different kind of intelligence, one that works without words, without logic, without effort. Let it work. You have earned exactly this. The exhausted mind that cannot sleep has a name, and a biology, and a path forward. But right now, in this moment, none of that matters. Right now, there is only this: the dark, and the quiet, and the breath, and the very old, very patient wisdom of a body that knows exactly what it needs. Let it have it. Simply, finally, completely. Let it have it. And so, our quiet journey through the exhausted mind comes to a gentle close. We traveled from the first whisper of adenosine building in the waking brain to the deep, patient work of the VLPO neurons assembling sleep. We traced the hyperarousal that holds the wake switch down, and the quiet chemistry of what finally releases it. We discovered that the body's desire for rest is not a wish but a biological certainty, one that, when given space, always finds its way. From the cortisol curve of a long evening to the glymphatic clearing of the deep night, we glimpsed how much the darkness does, and how little of it requires our participation. The exhausted mind reminds us that the line between effort and rest is not always visible, that we can move past it without noticing and only feel the crossing in the quiet of night. Much of the healing happens in silence, in the slow chemistry of restoration that asks nothing of us except our willingness to yield. Sleep shows us, night after night, that the most essential things are not done by striving, but by allowing, by pausing to let it happen. We glimpse the extraordinary in the ordinary act of simply closing our eyes. In these final minutes, take the deepest breath you can, as deep as possible. Think about unity of every thought you've had today, every feeling, every moment, all of it moving through you, like weather through open sky. You are not separate from the rest that is coming. You are already part of it. Let your entire being dissolve into the soft, unheld darkness, the place before thought, where the mind finally stops narrating and simply rests. Prepare for deep sleep. No boundaries left, only peace. These quiet facts about the exhausted mind were made for nights exactly like this one. Perhaps a gentle like or subscribe could carry this peace to another tired mind somewhere in the dark. Someone else, right now, is lying awake, just as you were. One quiet tap, one more sleepy soul, finding their way here. But there's no need to do anything now. Nothing at all. You've traveled far tonight. Not across miles, but inward, into the architecture of your own tiredness. And through it, toward rest, you can allow these thoughts of the exhausted mind to fade, now, like the last few words of a conversation drifting softly away, leaving only the warm, unheld quiet behind. Let your breathing deepen. Let your body feel heavier, as if a gentle, patient gravity has found you here and is simply holding you. If sleep comes, let it carry you the way the tide carries what it finds. Not with force, not with hurry, but with the soft and inevitable authority of something much larger than effort, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the brain will still be doing its patient, beautiful work. The chemistry of rest will still be available to you. But tonight belongs to stillness. Rest well, sleepy soul, and remember, the mind that could not stop was never broken. It was only waiting for permission. Good night.